So this is those cheap green 4S 4 ampere modules, lithium battery charger labeled as lithium battery charger. This is a boost module definitely because it takes 5 volt input and it converts it to 16.8. No, it does not convert it to 16.8. If I show you, it will be showing as somewhere around 19. It's fluctuating. 17, 18, 19, 17, 18, 17, 18, 17, 19. So it's very garbage, not because the voltage is fluctuating, because when I attached a load across it, let me put the multimeters probe here to always monitor the voltage. When I put load, how much load, 10 ohm load, or we can say uh, we can calculate the wattage. Okay, it's 10 ohm load, 2 to 5 am power resistors in parallel. So let's connect them and see. So it's ready means that the power is getting delivered. The voltage has dropped to 8.37 volts, and as the module gets warm, when the ampere, currently the ampere will be how much, the resistance here is 10 ohms, the voltage here is 8 ohms. So you can definitely calculate the ampere here using ohms law. So the main motto of my video is not about how much power it can deliver. The main motto is that the output voltage dropped below 8 volts. Okay, below 8 volts when drawing continuous power from output. So definitely it can't. So when there is no current using, I mean when there is no supply here, uh, the output voltage is 18 volts, but when I do attach a supply, it drops below 8 volts, and it definitely can't charge a 4S battery by this way. So it's a very garbage kind of module. Definitely you should uh, you guys should never buy this kind of modules, because these are not efficient and these are not actually meaningful. Because let me explain to you how such module can be manufactured, or which kind of procedure they should follow. First of all, the main principle here is that there are some ICs, some Schottky diode, inductor and capacitor. Although they are not any huge kind of capacitor, they are all ceramic small capacitors, hence the fluctuating voltage. If there is any big electrolytic capacitor, then there should not be any fluctuating voltage. But the fluctuating voltage alone is not the problem. The main problem is the lack of power rating here, because it drops 8 volt when drawing around 1 to 1.3 ampere, and sorry, 1.6 ampere. And because if it delivers a 16 volts, or 16 to 17 volts, then you are attaching a 10 ohm resistance will be 1.7 ohms of current, and that's the current which I need to charge my batteries. Typically be 1C or less than 1C, and 1.6 is for my batteries is 0.7 C kind of okay, because my battery capacity is 2600 mAh. So okay, the main thing is not that. The main thing is that these modules convert 5 volt from input to 16.8 volts in the output, and due to there is not any kind of electrolytic capacitor for charge storage and or filtering application, the output fluctuates between 17, 18 and 16 volts, which is not a huge problem. But the main problem is the lack of power. So and you need to understand that if a module needs to be delivered such power that it will be, so such modules delivered approximately 1.3 ampere of current at 16.8 volts. So if you multiply the voltage and current, you will get around 30, less than 30 watts of power is needed almost 30 watts of power is needed when charging the 4S battery pack, because there is some kind of efficiency loss. I mean, these modules are not 100% efficient, around 80 to 90% efficient there. Hence I said that around 30 watt of power they should handle. But you need to imagine, if I draw 30 watts of power from 5 volt input, you need to be getting around how much ampere? 30 divided by 5, 6 amperes. So 6 amperes of current, 6 ampere is not a joke. It is not, it's not a joke. 6 amperes. So such designs where 5 volt input and 16.8 volts output is just a gimmick, because there are not any kind of sources rather than batteries which can deliver 6 amperes in the input terminal, because our adapters are not capable enough. Hence they use PD protocol, switching from 5 volts to 9 volts to 12, 15, 20. So there are not any module which can be delivering 6 ampere in 5 volt range, other than the batteries. So no one charging battery using batteries, so that's the main thing. Whatever, so these modules are conceptually wrong. There are not any modules needed to convert 5 volt to 16.8 volts, because 16.8 volt is used to charge batteries, and it's impossible to do this by this way, by this kind of shit. So what we can do is that, first of all, we need a PD trigger module attached to the such module. This kind of module, a small portion will be a PD trigger, which will trigger the 20 volt supply of the PD adapter. Then that 20 volt will be bucked down, and the buck module should have the built-in and efficient way to limit the current up to 1.5 ampere. Why 1.5 ampere? For 1p 4s batteries, 1.5 ampere is more than enough. But if you use 2p or 3p, then you may need higher ampere, but lower ampere also do the work. It will be a lengthy process to charge the batteries. So typically people don't use huge parallel batteries, particularly people like me who uses 4s batteries. So typically you may build a 4s 2p or even 3p. In those purposes 1.5 ampere is still not that bad. So my main motto is that I need to build a module which will be able to, first of all, negotiate with the PD supplies, negotiate for 20 volts. Then 20 volt will be feed into a buck module. The buck module will be efficiently and space efficiently designed. I mean, the space or the size of the module will be smaller, but such that the current, the ampere rating would be 1.5 ampere. I don't need more than 1.5 ampere. I don't need 2 ampere, 3 ampere, which a 4015 can deliver. So I have a 4015 lying around. You can see here. So this is a 4051 buck module. This 4051 buck module has a CC and CV. So this module can deliver more than 3 ampere, but I don't need them, and I don't need the current control capability in the module. I need a simple module like this. Where is the module? Yeah, like this. I need a simple module which will first negotiate for 20 volt, then it will buck down the 20 volt into 16.8 volt, and will be able to smoothly deliver 1.5 amps, no matter the how small the load is. I mean, how the resistance of the load is how much lower, because when the batteries are mostly discharged at around 3 volts, it can eat the current, because of the very low internal resistance. And for that reason we need a CC, current control source, to charge them. So if the source itself is thermally throttled or manufacturing wise throttled to 1.5 ampere, then it would be great. So if I summarize my video, first of all, this module is complete garbage. Don't use this module. And this module can be improved. I mean, this kind of modules can be replaced by a module which, first of all, negotiate for 20 volts, then buck them out. The design should be space efficient, such a way that it can highly mostly deliver 1.5 amps, not more than that. There are not any CC protection, CC adjustment needed. I mean, I don't want to adjust the CC part, because I want it to be defaultly 1.5 amperes. Okay, so there are not any kind of extra 10k pot needed. Choose the resistance accordingly for the 1.5 ampere current rating. So that's the total video. That's the process of making a ideal 4S battery charger using a PD supply. And if myself want to do that, there are some handy options. First of all, I have a PD trigger module which can negotiate for 20 volt. So here is the module. Yeah, this module can negotiate for 20 volt, most definitely. There are some smaller modules also. So I have the option to negotiate to 20 volts with a space efficient design, because there are some small PD trigger modules. And secondly, I need a buck converter, not this kind of bulky design. I need a very size efficient, space efficient design, which does not have a current adjustment port, but will be the port will be set such a way that there should not be any port. The resistance bridge or the resistance divider should be such a way that the current would be 1.5 ampere without any thermal throttling, and merge them, I mean the PD trigger and that kind of buck module, to make a ideal 4S charging module. And currently I don't have such knowledge to make PCBs and make my design came true. Hence I am combining these two, this buck module and this PD trigger module together. So it does the work, without thermal throttling, but it's a very bulky design which is not a pocket friendly, I mean portable enough to make a power bank out of 4S batteries. So so I am currently thinking how to make it much more size efficient or space efficient. If you guys have any idea to charge my 4S battery, then you can comment. So this is the 4S battery for which I made this video. I need a charger to charge this battery. This is the BMS. This is the PD trigger to charge my phone, ultimately making a power bank out of 4S battery. And there is a switch. This is a very prototype design. If the design is complete with some Vero board and some white PVC and acrylic board I bought today. So after finishing the product, I will be discussing that separately on my YouTube channel. Currently, I had purchased some things on Maker Bazaar and realized that this sheet is no use to anyone. Please don't purchase this. Oh, by the way, I purchased it for 70 rupees.